Good afternoon and welcome to the 21st Annual Exhibit of Hydrogen and Fuel Cell Technology. We've been here for quite some time discussing the most recent developments. There's some very important developments. All of our improvements in this technology relies, of course, on testing equipment. And testing equipment is fundamental to the research and development and application. We have a specialist from Turkey to talk about this problem. His name is Dr. Furkan Dundar. He's the director of BilveTek in Istanbul. Please welcome with me Dr. Furkan Dundar. So,
Hello.
Welcome. Hello. We're going to get to these devices, of course, which are always fascinating. We like the toys. But before we get to those toys, perhaps you could tell us a bit about BilveTek, where you're located, what you do.
Okay, BilveTek is located in Istanbul, Turkey, and it's founded in 2012. It's a 3-year young company. We mainly focus on manufacturing fuel cell test equipment and battery testers, load banks, and other fuel cell products. We are a consumable supplier in Turkey, fuel cell consumable supplier in Turkey. And I guess BilveTek focuses on developing new products which researchers, fuel cell researchers require, and we are developing new and unique accessories for fuel cell testing, like we have a new corrosion cell, which is a miniature corrosion cell, which you can test you can test the corrosion properties of the fuel cell components in small quantities, and so on. So we mainly focus on developing fuel cell components, fuel cell testing equipments, and fuel cell components. We also manufacture MEAs. We sell it to Turkish market, but we came here to expand our market and advertise our products to global business. You can visit our booth at C40-1, which is behind, a little behind. It's not on the main road. We have a small booth. Please, we will be happy to tell you about our products. We have manufactured a solid oxide test station also. We make our test stations ourselves. Our load banks are custom made, and we manufacture products depending on requests.
Whenever I talk to someone who does testing, they know a lot of the finer details, of course, in creating fuel cells. So it's sometimes good to ask them the direct question. So why are fuel cells not commercialized yet? What's missing? Where have they failed?
Okay, I'm working on fuel cells more than 10 years. There were major improvements in fuel cells. However, I can say that there are 3 issues that needs to be improved. First of all, the performance. Secondly, the cost. And third, the durability. There are some improvements in performance and cost throughout the last decade. However, the durability of fuel cells is still a big issue. I mean, the fuel cell performs well today. However, it may not perform as much as good as it performs today, tomorrow. So we are not sure about the tomorrow's performance. So the durability of the fuel cell is a critical issue. And how can we overcome this durability issue is we need to solve the problems that results on performance drop. And the way to solve a problem is first to understand what is the problem. And in order to understand the problems, we need to monitor what is going on. We need to understand what is going on. And in order to understand what is going on, we need to do in situ and ex situ characterization tests. So
I have to pause you there because in situ and ex situ characterization tests, are you going to define that for us?
Okay, those terms may not sound familiar, so I need to explain it. I would like to explain it with a story, a nice story. Once a surgeon had a problem with his car. When he was going, the car broke down. So he called a mechanic, and he asked the mechanic to fix the car. The mechanic was an expert in his business, and he came to fix the car. And while he was fixing, he said that you and me, we are doing actually the same business. You are fixing the people, I'm fixing the engines. However, people respect you more, but not me as much as they respect you. What might be the reason? Actually, we are doing the same job. Actually, the surgeon replied that try to fix the car when the engine is running. So I mean, there's a big difference. I mean, and if I correlate that story with in situ and ex situ, in situ methods are monitoring the fuel cell while it is running, and ex situ methods are monitoring the fuel cell when fuel cell is not running. So we require both methods to understand what is going on. So in situ and ex situ methods are both required to monitor or solve the mechanism that results in drop in fuel cell performance. So they are required to solve the durability problem of the fuel cells.
Okay. We can go through, of course, a number of parameters and testing characteristics that you do. Before we forget, though, we have this device on display here, and generously, Furkan allowed me to say that this won the prize for the ugliest device on the fuel cell exhibit this year, but you've promised to bring a prettier one next year, right?
Yeah, definitely. We focused on developing a good equipment. It works good. I mean, I can say that it is it has one of the lowest internal resistance in the market, but it looks ugly. I mean, that's a big issue for us now, because next year we decided to have a product which also looks good.
Okay, but it is a highly functional device, and this is, of course, as a lot of your testing equipment, this is for a hydrogen PEM cell. Right?
Yeah, that's actually not on the PEM type. It can be used in solid oxide fuel cells because it's a load bank.
Okay.
We manufacture the test stations for PEM type fuel cells and solid oxide fuel cells, which both use this load bank that we manufacture customly. And we made it as a standard product now, and we came here to advertise it.
So you've defined for us in situ and ex situ. Let's go on and discuss the actual methods that are used for fuel cells. It sounds actually weird. I've talked with some people who do testing equipment. It's vital to know how impurities affect fuel cells. It's vital to know how the surface areas and the catalysts are deteriorating or not deteriorating. What sort of test parameters and monitoring methods do you use for the PEM cells?
Okay, actually about in situ monitoring methods, I believe the major method is performance test, which is conducted with this load bank. So what is the performance of your fuel cell? However, if you want to define the mechanisms that results in fuel cell failure, you need to conduct some more tests. You need to check the surface area, and you need to check you need to check the mechanisms that are taking place in the fuel cell. The surface area is usually checked with a potentiostat, and the experiment is cyclic voltammetry. So the active surface area is the important issue for us, and it's controlled by the cyclic voltammetry method. But among these methods, I believe the most important one is impedance spectroscopy. An impedance spectroscopy tells you the resistance, capacitance, and inductance of the fuel cell at different frequencies. So I need to explain that, I guess, because some slow mechanisms like diffusion take place at low frequencies. So it's a slow mechanism, so you can monitor it at low frequencies. However, fast mechanisms like electron movement takes place at high frequencies. So you can monitor the resistance of the fuel cell at high frequencies. However, you can monitor the mass transport losses of fuel cells at low frequencies. So this impedance spectroscopy measures the resistance and capacitance and also inductance of the fuel cell at different frequencies. So you can understand that if the resistance of the fuel cell has changed, or if you have problems with the mass transport issues, or if you have changing capacitance of the fuel cell. So fuel cells are normally like batteries. However, they have internal resistance. In addition to that, they have some capacitive behaviors. So fuel cells, capacitive behavior and resistance can change during this time. And for example, if their internal resistance becomes too much, then it's like their end of life is approaching. So that might be due to different mechanisms that you mentioned, like poisoning, like degradation, like agglomeration. Those methods, the impedance spectroscopy can tell us which the fuel cell performance, the fuel cell resistance, fuel cell capacitance is changing in which direction.
The PEM cells that we're talking about, they have this sort of Goldilocks problem. You know, Goldilocks always says a little bit too hot, a little bit too cold, just right. And there's something similar to the PEM cells, that is, they don't like to be dry completely. They don't like to be too wet completely. So obviously there has to be some sort of monitoring technology to make sure that things are just right. So what's the Goldilocks solution to that?
Okay, as I guess we all know that fuel, maybe not all of us, but fuel cells work better in humidified environments.
Yeah.
So sometimes you humidify too much, sometimes you dry it too much. You need to keep the fuel cell in optimum humidification, and optimum humidification it can be monitored by impedance spectroscopy. So if the resistance of the membrane increases, then you know that you are drying the fuel cell. So you can monitor the resistance of the membrane by looking at the high frequency resistance. If you have too much water in the fuel cell, then your mass transport losses will increase. So your charge transfer resistance of your fuel cell, which is monitored by impedance spectroscopy, increases. So depending on which resistance or which capacitance changes, you can say that it's flooding or it's drying. So you can monitor the fuel cell while it is working with this method.
Mm-hmm. So you've described impedance spectroscopy, voltammetry, the performance test. Do you ever deal with how the use of platinum in PEM cells functions?
Actually, platinums which are the commonly used catalyst material in fuel cells are in nano size. So they are usually the platinums. We also in our company we synthesize catalysts and we sell them, and we sell it as MEA also. And those nano size catalysts are not thermodynamically stable. They want to get bigger and bigger because small materials have high energies, and in general materials want to lose their energy. So nanoparticles will lose their size by time because will agglomerate with other nanoparticles, and they expand and they become large particles after some time, which results in a active area loss. So nano-sized platinums are not there anymore if you run the fuel cell, especially at harsh environments, for a long period of time.
I've always wondered how to explain one of the typical combinations that PEM cells are used in right now. So I'm moving on to applications just because you're in the testing department. You know when fuel cells fail that there's typical explanations for failure that happens quickly. They often combine a battery with a PEM cell. And I've heard the explanation. The PEM cells, well, the cars stop and go, of course. There's acceleration, there's high demand points, there's medium demand points, there's zero demand points. So you get a demand curve that goes like this. Now, I'm not really sure whether a PEM cell likes to do that. I certainly know that the atomic power plants, one of their problems is they have one speed. It's like on or off for optimal operation. And the combination with batteries allows to have a balance between the two supplies of energy. So is it the PEM cell that likes to operate at a constant level? Is there a large fluctuation? Are there parameters for minimum demand and maximum demand? How do they function?
Actually, we can compare, we can say that PEM fuel cells behave like internal combustion engines. At low power, they are very efficient. At high power, they are not as efficient as they are in low power region. So in order to have high efficiencies, we normally try to keep fuel cells in low power region. And if we require high power for a short period of time, it's good to hybridize it with a battery. So batteries are actually used to keep the efficiency high. So fuel cells can give high power. They have that capability. However, they are not efficient in that region, so it's not meaningful to keep the fuel cells to run the fuel cells at high power.
Mm-hmm. Okay. Looking at the state of development now, I suppose we have to ask a philosophical question towards the end of our conversation here. You offer cutting-edge technology for testing. You develop your own membranes. You're both a businessman and an academic. And from the business perspective, we're all looking for the next commercial environment. Where are we going to sell stuff? Where do you see the fuel cell industry going? In what areas do you expect to see growth for your business?
Okay, in general, new technologies, they found their market usually in aerospace engineering, and then military, and then expensive applications. Fuel cells is in the level of expensive applications now, because it is used in aerospace shuttles in 1960s, and it's used in military applications, especially battery chargers and unmanned aerial vehicles. It is being used now, and nowadays it's also started to be used in expensive applications like GSM stations in rural areas. So I see that every new technology comes into market step by step. It cannot come very fast. So fuel cell is in the third step now. So the next step will be the next step is not fully commercialization, but it will be commercialized slow by slow. So we have a couple of steps more, but in some technology, some sectors, now it's required, even today.
Well, that's why we need you, of course, and your testing equipment to keep
so
moving
much.
forward. It's been a pleasure talking to you. I've been talking to Dr. Furkan Dundar, who is the director of BilveTek, located in Turkey, in Istanbul. You'll have to visit his booth for further conversation. Please do. These specialists are always informative. C40/1 in this direction is where the booth is located. Furkan, it's been a pleasure talking to you. I hope to see you next year.
Okay, thank you so much. It's been a pleasure to meet with you and talk with you.
Thank you.
Thanks for...
See you back next year with the pretty alternative to this device here. We'll be returning shortly and continuing the conversation on fuel cells. We'll be talking about with Ski Muir-Milburn, CEO of Varix, about efficient, compact, cost-effective fuel cell air supplies, a component that is vital to the fuel cell operation. So stay tuned. Up in a minute.